Out in the vast universe, something is pulling us, a cosmic secret known as the Great Attractor. It's a force so immense, so mysterious, that it has captured the imagination of astronomers and dreamers alike for decades. Hidden far beyond the reach of ordinary sight, it tugs at entire galaxies, including our own, as if the universe itself is being drawn toward an invisible destination. It's not a star or black hole, but a massive, unseen concentration of mass, hidden behind the Milky Way. Shrouded by thick clouds of cosmic dust and the blinding light of countless stars, the Great Attractor remains one of the most elusive objects in the cosmos. Its true form is masked, making it nearly impossible to observe directly with traditional telescopes. For centuries, we've watched galaxies, including our own, drawn toward this mysterious point at incredible speeds. The entire region of space seems to be in motion, as if responding to a silent call. Scientists have measured this movement, noting that our galaxy and thousands of others are racing toward the Great Attractor at over 2 million kilometers per hour. The Great Attractor challenges our understanding of the universe's structure and gravity. Its gravitational pull is so powerful that it warps the very fabric of space-time, bending light and distorting the paths of galaxies. This phenomenon has forced scientists to rethink what they know about the forces that govern the cosmos. Is it a colossal cluster of galaxies, or something even stranger, perhaps a concentration of dark matter? Some theories suggest it could be a vast supercluster, while others hint at unknown forms of matter or energy. The true nature of the Great Attractor remains one of the greatest unsolved mysteries in astronomy. Despite our best telescopes, its true nature remains elusive, a ghost in the cosmic machine. Even the most advanced observatories can only catch glimpses of its influence, leaving us with more questions than answers. The deeper we look, the more the mystery seems to grow. This pull is a reminder that we're part of a much larger, dynamic, cosmic web. Every galaxy, every star, and every planet is connected by invisible threads of gravity, woven together in a vast tapestry that stretches across the universe. The Great Attractor is a focal point in this grand design, hinting at secrets yet to be revealed. Now, in the year 2300, humanity is ready to answer the call, not just to observe, but to go there. With technology that once existed only in science fiction, we prepare for a journey that will take us farther than any human has ever traveled before. Our mission is not just scientific, but deeply human, a quest for understanding and discovery. We will journey across intergalactic space to see the Great Attractor with our own eyes. The voyage will be long and perilous, but the promise of uncovering the universe's secrets drives us onward. For the first time, we will witness the source of this cosmic pull up close, hoping to unlock answers that have eluded us for generations. This is humanity's boldest step into the unknown, a quest to understand the forces shaping our universe and ourselves. As we set out on this unprecedented journey, we carry with us the hopes and dreams of all who have ever gazed up at the stars, wondering what lies beyond. The decision to journey to the Great Attractor was not the ambition of a single nation, nor the dream of a select few. It was a choice made by all of humanity, a collective leap into the unknown, driven by our shared curiosity and the desire to understand our place in the cosmos. In the late 22nd century, the world came together as never before, forming the Global Space Alliance. Old rivalries and borders faded into the background as leaders and citizens alike recognized that the future of our species depended on unity and cooperation. For the first time, humanity set aside its differences to pursue a destiny among the stars. Project Odyssey, the ambitious mission to the Great Attractor, quickly became the ultimate symbol of this newfound unity. It was more than a scientific endeavor, it was a beacon of hope, a testament to what we could achieve when we worked as one. Engineers, scientists, and visionaries from every continent joined forces, sharing knowledge, technology, and dreams. Their collaboration transcended language and culture, forging bonds that would shape the mission and the future of humanity itself. The Mission Control Center, built on the African continent, stood as a powerful symbol of global cooperation and inclusivity. It was a place where the world's brightest minds gathered, united by a single purpose. Funding for Project Odyssey came from a worldwide trust, with contributions from nations, organizations, and individuals. This unprecedented act declared that the pursuit of knowledge and exploration was not a privilege, but a universal right. open to all, and for the benefit of all. The mission's announcement sparked a revolution in education, inspiring a new generation of dreamers and explorers. Classrooms across the globe buzzed with excitement as children imagined themselves among the stars, their imaginations ignited by the promise of discovery. Preparation for the journey took decades. New technologies were developed and rigorously tested on the Moon and Mars, each breakthrough bringing us closer to the stars and teaching us more about our own resilience and ingenuity. The challenges were immense, demanding not only technical expertise but also creativity, adaptability, and the wisdom that comes from diverse perspectives. It was the collective genius of humanity that made progress possible. Every system aboard the Odyssey, from life support to navigation, propulsion to communication, was the result of global synergy. Each component told a story of collaboration, innovation, and trust. Project Odyssey was more than a mission. It was living proof of what humanity can achieve when we come together, united by a vision greater than ourselves. Together, we set our sights on the stars, embarking on a journey that would forever change the course of human history. To reach the Great Attractor, we needed a new kind of ship, the Newton. Built in orbit at the Lagrange 2 shipyard, the Newton was a city in space over 2 kilometers long. It was self-sustaining, with hydroponic farms, medical bays, labs, and living quarters designed for generations. Its metamaterial hull shielded the crew from cosmic dangers, while rotating sections provided artificial gravity. Every detail was engineered for survival and comfort on a decades-long voyage. The Newton was more than a vessel. It was a home, a laboratory, and a symbol of human ingenuity. Humanity's hopes and dreams would ride with it across the cosmic ocean. Crossing 250 million light-years demanded more than rockets. The Newton was equipped with an Alcubierre-Tyson warp drive. This engine bent space-time, contracting it ahead and expanding it behind, moving the ship within a warp bubble. At its heart was a microscopic artificial black hole, generating immense energy for the drive. The journey wasn't a single leap. The Newton made controlled jumps, navigating the hazards of intergalactic space. Advanced sensors plotted safe courses, while the ship paused between jumps for recalibration and observation. Developing the warp drive and singularity engine took a century of breakthroughs in physics. The Newton's technology was a triumph of human curiosity and determination. It was the key that unlocked the universe beyond our galaxy. The Newton's crew were pioneers, scientists, engineers, artists, and diplomats, chosen from millions worldwide. 150 specialists formed a microcosm of humanity, united by purpose and rigorous training. Commander Dr. Eris Thorne led a team prepared for any challenge. Each member cross-trained in multiple disciplines. They became a family, carrying with them the echo of Earth, a digital archive of our art, knowledge, and genetic heritage. As ambassadors, they represented all of humanity, ready to share our story if they encountered other life. Their mission was more than exploration. It was a message in a bottle, cast into the cosmic sea. They embodied humanity's hope, curiosity, and drive to connect. January 13, 2300, Launch Day. The world stood on the edge of a new era, the air thick with anticipation and the weight of history pressing down on every heart. All eyes turned skyward, fixed on the Newton as it hovered at Lagrange 2, a silent sentinel poised between Earth and the stars. Across continents and oceans, billions gathered, on city streets, in remote villages, in living rooms and public squares, united by a single moment. The world watched as the crew readied themselves, a sense of awe and hope binding humanity together like never before. Commander Thorne's voice echoed through the ship and across the globe. With a calm authority, she gave the order. Fusion thrusters ignited, and the Newton began its slow, deliberate departure from Earth's embrace. Cheers erupted, mingled with tears of joy and bittersweet pride. Strangers embraced, families wept, and the world celebrated as humanity took its first true step into the unknown, leaving its cradle behind. Inside the Newton, the crew worked in perfect harmony, monitoring thousands of systems. The Singularity engine, a marvel of human ingenuity, demanded their constant vigilance and focus. Every movement was deliberate, every command precise, a symphony of teamwork honed by years of relentless training and shared purpose. Hours slipped by as the Newton sailed past Neptune, reaching the edge of the solar system and its designated jump point, where the familiar faded into the unknown. Through the ship's windows, the solar system dwindled to a scattering of distant lights, each one a memory of home, growing fainter with every passing moment. All systems ready. Prepare for warp jump, Thorne announced, her voice steady, carrying the hopes of an entire species. Around the world, a hush fell. In homes, in control rooms, in crowded plazas, people held their breath, hearts pounding in unison. The singularity engine thrummed with power, and outside, the stars began to twist and stretch, reality itself bending as the Newton prepared to leap beyond the known. In a blinding flash, the Newton vanished, slipping from the solar system and into the vast, uncharted dark. Silence lingered in the aftermath, heavy with hope, wonder, and the promise of discovery. Humanity's greatest journey had begun, a voyage into the deep unknown, carrying the dreams of generations. As dawn broke over Earth, the planet exhaled, forever changed by the courage to reach for the stars. Life aboard the Newton settled into a rhythm, warp jumps, observation and discovery. The crew witnessed sights no human had seen, the emptiness between galaxies, the Milky Way, a faint smudge behind them. Astrophysicists mapped the cosmic web, biologists searched for organic molecules in the intergalactic medium. Every observation rewrote our understanding of the universe. Life on board balanced work, research and community, meals, celebrations and support in the hydroponic gardens. Children were born, a new generation of explorers who knew only the ship as home. Dangers persisted. A near collision with a rogue gas cloud forced a tense spacewalk for repairs. The void was unforgiving, demanding constant vigilance. Yet, each challenge strengthened the crew's resolve. The Newton pressed on deeper into the unknown. After decades, the Newton reached the edge of the Norma Cluster, the heart of the Great Attractor. The sky blazed with galaxies, a crossroads of cosmic activity. Sensors revealed the source, a vast network of dark matter filaments, more massive than anyone had imagined. The crew mapped this superstructure, solving a centuries-old mystery. Biologists scanned thousands of star systems for signs of life, technosignatures and biosignatures. The sheer scale was overwhelming, but hope persisted. Perhaps we were not alone. The Great Attractor, a cosmic hub, seemed a likely cradle for life and intelligence. The crew listened, learned, and searched for connection. Their work was the ultimate quest, to find our neighbors in the grand cosmic city. The Newton's discoveries at the Great Attractor transformed our understanding of the cosmos. Mapping the dark matter network revealed the universe's true architecture, inspiring new fields of science. The mission proved intergalactic travel was possible, igniting a new age of exploration. Humanity began to see itself as a galactic species, with the stars of other galaxies within reach. The Odyssey mission's cultural impact was profound, uniting Earth with a sense of shared purpose and cosmic identity. The crew's journey became a story of hope, curiosity, and peace. We reached across the void not with fear, but with wonder. The Odyssey mission proved that no challenge is too great when we are united by science and inspired by the universe. The Great Attractor's pull led us to discover our own boundless potential. Our journey had only just begun. Imagine you're in a boat, adrift on a vast, dark ocean, feeling a persistent pull toward an unseen destination. This is the situation of our galaxy, the Milky Way, part of a cosmic voyage, drawn by a mysterious force. That force is the Great Attractor, one of the universe's most captivating mysteries. Our journey to understand it is a journey into the fabric of the cosmos. For centuries we thought we had mapped the heavens, but the universe always surprises us. The discovery that our entire local group of galaxies is being tugged across space was humbling. It revealed forces and structures far grander than we imagined. The story of the Great Attractor is a cosmic detective story. The clues are subtle shifts in the light from distant galaxies. The suspects, vast, unseen concentrations of mass. The crime scene, the entire observable universe. To solve this, we must become cosmic detectives, using powerful telescopes and our curiosity. We must look into the darkness and ask, what is out there? So, come with me. Let's embark on this journey together. We'll travel across millions of light years, through clusters of galaxies and voids of space. We'll explore the evidence, examine the theories, and confront the unknowns. The Great Attractor is more than a massive object. It's a signpost to deeper understanding. It reminds us that the universe always holds more wonders. Our cosmic voyage has a destination, and our quest is to discover what awaits us there. Where is the Great Attractor? Look toward the southern sky, near the constellations of Norma and Triangulum Australe. It lies about 220 million light-years away, a distance almost beyond comprehension. Yet, its influence is felt right here in our galactic neighborhood. The Great Attractor is hidden behind the plane of our Milky Way, like a mountain range obscured by a dense forest. This region is called the Zone of Avoidance, once thought empty but actually just hidden. The Milky Way's stars, gas, and dust act as a cosmic curtain, blocking visible light. That's why the Great Attractor remained a secret for so long. Scientists had to find clever ways to peek behind this curtain, using infrared and X-ray wavelengths. These revealed not a single object, but a massive concentration of galaxies, a supercluster bound by immense gravity. The Great Attractor isn't a single giant thing. It's a gravitational focal point, a region with unusually high mass density. The Norma cluster sits at its heart, but even it doesn't have enough visible mass to explain the pull. That's the core of the mystery. We can see the effects and pinpoint the location, but the visible matter doesn't add up. Something massive and invisible must be contributing to its gravity. The Great Attractor challenges our understanding of what fills the universe. It's a gravitational anomaly that hints at hidden structures. Our search for answers pushes the limits of observation and theory. The more we look, the more we realize how much remains unseen. The Great Attractor is a cosmic riddle, waiting to be solved. To understand the Great Attractor, we must confront the universe's dark side. Everything we see, stars, planets, galaxies, is just a tiny fraction of what's out there. Ordinary matter makes up less than 5% of the cosmos. The rest is dark matter and dark energy, mysterious, invisible, and dominant. Dark matter doesn't shine or reflect light, but its gravity shapes galaxies and clusters. Dark energy, even stranger, pushes the universe apart, accelerating its expansion. These unseen components are essential to the Great Attractor's mystery. The gravitational pull we measure can't be explained by visible galaxies alone. Only with a colossal amount of dark matter does the math work. The Great Attractor is a dense concentration of this invisible substance, a gravitational well pulling everything nearby. It's a physical manifestation of the universe's hidden majority. Everything in the universe is in motion. Earth spins, the sun orbits the Milky Way, and the galaxy itself moves. For decades, we thought galaxies simply drifted apart with the universe's expansion. But in the 1970s and 80s, astronomers found galaxies had peculiar velocities, motions, beyond the general expansion. Imagine a moving walkway. The expansion is the walkway, but galaxies can move on it too. Our Milky Way and its neighbors are part of a vast flow, all heading toward the Great Attractor. The speed is astonishing, over 1 million miles per hour. We won't crash into it soon, but the fact that we're moving at all means the source must be incredibly massive. The Great Attractor acts like a lead dancer dictating the steps for thousands of galaxies. It creates a gravitational basin and we're sliding down its side. This motion is a vital clue. By measuring these flows, we map the universe's mass, visible and dark. These flows reveal the cosmic landscape, showing us superclusters and voids, even when we can't see them. The Great Attractor's pull is a window into the universe's hidden structure. Our journey is guided by gravity's invisible hand. The zone of avoidance kept the Great Attractor hidden, but science found a way through. Astronomers used radio and X-ray telescopes to peer behind the Milky Way's glare. They discovered the region was teeming with galaxies, anchored by the massive Norma cluster. This cluster, with hundreds of galaxies, confirmed a huge concentration of mass. X-ray observations revealed hot gas between galaxies, shining brightly and adding to the mass tally. Yet, even with all this, the visible matter was only a fraction of what's needed to explain the gravitational pull. The motion of our galaxy and others pointed to a much larger invisible mass. Most of the Great Attractor's mass must be dark matter. The visible galaxies are just the tip of a cosmic iceberg. The true structure is vast, hidden, and mysterious. Our neighborhood is shaped by forces we can barely detect. The Great Attractor is the anchor of a much larger cosmic web. In 2014, our cosmic address was redrawn. Scientists mapped galaxy motions, not just positions, revealing new boundaries for superclusters. The Virgo supercluster, once thought our home, is just a branch of a much larger structure, Laniakea. Laniakea contains 100,000 galaxies and stretches over 500 million light-years. The Great Attractor is its gravitational heart, the center of our supercluster. All galaxies within Laniakea, including ours, flow toward this common center. This redefined our place in the universe. We're not being tugged by something distant, we're following the gravitational pathways of our home supercluster. But the story doesn't end there. Laniakea itself is moving, pulled toward the even more massive Shapley supercluster. The cosmic dance continues with superclusters drawn by even larger structures. Our journey is part of a grand, interconnected flow. The universe is more complex and beautiful than we ever imagined. The quest to understand the Great Attractor is a story of brilliant minds. In the 1970s, the seven samurai astronomers found galaxies moving in a bulk flow toward a single point. Their work postulated the Great Attractor's existence. Vera Rubin's studies of galaxy rotation curves revealed the need for dark matter. Galaxies were moving too fast for visible mass alone. The discovery of the cosmic microwave background, CMB, provided another clue, a cosmic Doppler shift confirming our motion. More recently, Brent Tully's team redefined our supercluster as Laniakea, with the Great Attractor at its heart. Each discovery forced us to redraw the cosmic map. Science evolves, and so does our picture of the universe. The Great Attractor is not an anomaly, but the natural center of our home supercluster. Our understanding grows with every new observation. How do we study something hidden behind stars and dust, hundreds of millions of light-years away? The answer: multi-wavelength astronomy. Radio telescopes map hydrogen gas, revealing galaxies invisible to optical telescopes. Infrared telescopes see through dust, showing the glow of older stars. X-ray observatories detect hot gas in galaxy clusters. Each wavelength uncovers a different piece of the puzzle. Future instruments like the Square Kilometre Array will map billions of galaxies in stunning detail. These tools let us chart the cosmic web and uncover the universe's hidden structure. The Great Attractor's secrets are slowly coming into focus. Our journey has taken us from the mystery of our galaxy's motion to the heart of Laniakea. We've learned the universe is dominated by dark matter and dark energy, but many questions remain. What is dark matter? We see its effects, but its true nature is unknown. Is there a larger structure in the universe, or does the cosmic web extend forever? These questions drive astronomers to build bigger telescopes and devise new theories. The Great Attractor reminds us we live in a dynamic, evolving universe. We are not at the center. We are passengers on a journey toward a gravitational focal point we can barely see. Our quest for knowledge is our way of reading the cosmic map. The journey continues. The cosmos awaits. Imagine you're on a boat, drifting on a calm sea, the world around you silent except for the gentle lapping of water against the hull. The horizon stretches endlessly, shrouded in a soft golden light, and you feel both at peace and filled with wonder. You have no map, no compass, and yet you sense a subtle pull, as if some unseen current is guiding you forward, drawing you toward a destination you cannot see. You move steadily, almost imperceptibly, toward an unseen destination, guided by forces you can't quite comprehend. The journey is quiet, mysterious, and filled with anticipation, as if the universe itself is steering your course. This is not just a metaphor, it's the reality for our Milky Way galaxy. Our home in the cosmos is being pulled by an invisible force, a gravitational phenomenon known as the Great Attractor. Like the boat on the sea, the Milky Way is on a journey, drawn inexorably toward a mysterious region of space. The Great Attractor is a gravitational anomaly, a region with an immense concentration of mass, so powerful that its influence is felt across hundreds of millions of light-years. Galaxies, clusters, and even superclusters are all being drawn toward this enigmatic point, their paths subtly altered by its invisible hand. This cosmic enigma challenges everything we thought we knew about the universe. It raises profound questions about the nature of gravity, the distribution of matter, and the unseen structures that shape the cosmos on the grandest scales. We like to believe we have a firm grasp on the workings of the cosmos, but mysteries like the Great Attractor remind us that we are still at the very beginning of our journey. Each discovery opens new doors, revealing how much more there is to learn. The Great Attractor tugs not only on space-time, but also on our curiosity. It urges us to ask deeper questions, to look beyond the obvious, and to wonder what else might be hidden in the vast darkness between the stars. The story of the Great Attractor is a testament to scientific discovery and the relentless human spirit of inquiry. It is about the drive to understand, to seek out the unknown, and to push the boundaries of our knowledge, no matter how daunting the challenge. When astronomers first noticed that galaxies were moving in unexpected ways, they realized they had stumbled upon a mystery of epic proportions. The universe was not behaving as predicted, and something massive, yet unseen, was exerting its influence. This journey into the unknown is the very essence of science. It's about embracing the puzzles that the universe presents, chasing after anomalies, and daring to venture into the dark, guided only by data, intuition, and an insatiable curiosity. Scientists and explorers alike are drawn to the unknown, venturing into the darkness with nothing but their questions and the hope of finding answers. Each step forward is a leap into the cosmic night, illuminated by the faint glow of discovery. The Great Attractor is not just about gravity and galaxies, it's about the unyielding drive to understand the universe. It represents the mysteries that keep us searching, the questions that keep us awake at night, and the wonder that fuels our quest for knowledge. It compels us to explore the cosmic horizon, to peer ever further into the unknown, and to seek what lies beyond the edge of our understanding. The universe's unseen hand guides us onward, and our journey has only just begun. What is this cosmic titan lurking in the depths of the universe, and why does it have such a powerful hold over our corner of the cosmos? The Great Attractor is one of the most mysterious and influential features in the observable universe, and its story is as fascinating as it is complex. The Great Attractor is a massive concentration of matter in the intergalactic medium, hidden behind the dense plane of our own Milky Way galaxy. For decades, astronomers puzzled over strange motions of galaxies, noticing that entire clusters, including our own, seem to be drawn toward a specific region of space. It's a gravitational focal point, not a single object, but a dense region of galaxies, dark matter, and hot gas. This region is so packed with mass that its gravitational pull can influence the movement of galaxies millions of light-years away, creating a cosmic tug-of-war that shapes the structure of our universe. Imagine a fog thicker in one area. The Great Attractor is like that, but with cosmic structures. Its true nature is obscured by the so-called zone of avoidance, a region blocked from our view by the dust and stars of the Milky Way, making it even more enigmatic. It's the center of gravity for our Laniakea supercluster, pulling us and our neighbors. The Milky Way, along with thousands of other galaxies, is being drawn toward this gravitational center at speeds of over 2 million kilometers per hour. The universe is expanding, but gravity can overpower this expansion locally. While most galaxies are moving away from each other due to cosmic expansion, the Great Attractor's immense gravity creates a local flow, drawing galaxies inward against the cosmic tide. The Great Attractor is a massive basin of attraction in space-time, a kind of cosmic sinkhole where the fabric of the universe bends under the weight of countless galaxies and dark matter. The name Great Attractor captures its immense gravitational influence and enigmatic nature. Despite its power, much about it remains hidden, fueling scientific curiosity and debate. It was coined by Alan Dressler, highlighting its scale and mystery. Dressler and his colleagues were among the first to realize that something unseen was orchestrating the motion of galaxies on a grand scale. The universe is dynamic, with epic forces shaping galaxies over billions of years. Collisions, mergers, and gravitational dances are all part of the cosmic ballet influenced by giants like the Great Attractor. The Great Attractor is a testament to the universe's evolving stage, a reminder that even on the largest scales, the cosmos is never static. It reminds us that the cosmos is a place of constant motion and discovery, where mysteries like the Great Attractor continue to challenge our understanding and inspire our search for answers. Why can't we just point telescopes at the Great Attractor? It's obscured by the dense plane of our Milky Way. This zone of avoidance is filled with stars, gas, and dust blocking our view. Imagine trying to see a mountain through a blizzard. That's our challenge. The Great Attractor is hidden, but its influence is undeniable. Scientists use infrared and radio waves to peer through the cosmic curtain. These methods reveal a massive supercluster, the Norma cluster, at the heart of the Great Attractor. Yet, its full form remains hidden behind our galaxy's veil. The discovery of the Great Attractor was a gradual realization starting in the 1970s. Scientists noticed our galaxy moving through space at 600 km/s. Initially, the Virgo cluster was suspected, but it too was moving. The 7 samurai astronomers found galaxies streaming in the same direction. The Virgo cluster couldn't be the culprit. Something larger was pulling us. Data pointed to a region obscured by the Milky Way. They discovered the Great Attractor by observing the motion of thousands of galaxies. It wasn't seen directly but inferred from cosmic breadcrumbs. This discovery highlighted the interconnectedness of cosmic structures. The Great Attractor's pull is a testament to the universe's gravitational dance. Studying the unseen Great Attractor requires scientific ingenuity. Astronomers use radio and infrared telescopes to see beyond the zone of avoidance. Radio astronomy maps hydrogen gas, revealing hidden galaxies. X-ray observatories detect hot gas in galaxy clusters, confirming massive gravitational wells. Peculiar velocities of galaxies help infer the location and mass of unseen structures. These tools allow us to map the cosmic flow and weigh the universe. The Great Attractor's study pushes the boundaries of technology and understanding. Why is our galaxy moving towards the Great Attractor? The answer lies in one of the most fundamental forces in the universe: gravity. But to truly understand this cosmic journey, we need to look beyond just our own Milky Way and consider the vast, interconnected web of galaxies that make up our universe. Gravity acts as the cosmic choreographer, orchestrating a grand dance that involves not just our galaxy, but billions of others. Every galaxy, star, and planet is caught in this invisible web, constantly pulled and nudged by the mass of its neighbors. The Great Attractor, with its immense and mysterious mass, creates a gravitational well so deep that it warps the very fabric of space-time. This region acts like a cosmic sinkhole, drawing in galaxies from millions of light-years away. Our galaxy, along with countless others, is essentially rolling downhill into this cosmic dimple, pulled by the irresistible force of gravity. It's as if we're all caught in a slow-motion river, flowing toward an unseen destination. But this journey isn't simple. It's a complex dance influenced by multiple partners, including the massive Virgo cluster and the even larger Shapley supercluster. Each of these cosmic giants exerts its own gravitational pull, shaping the paths of galaxies across the universe. Our motion is the result of countless gravitational nudges, pushes, and pulls, all adding up over billions of years. Scientists study these subtle movements to map out the invisible forces at play. The journey toward the Great Attractor is incredibly slow on human timescales, taking billions of years to unfold. Yet, on a cosmic scale, it's a dynamic and ever-changing process. However, the universe itself is expanding, driven by the mysterious force of dark energy. This expansion is causing galaxies to move away from each other, potentially preventing us from ever reaching the Great Attractor. It's a cosmic tug-of-war, a race between the gravitational pull of massive structures and the relentless expansion of space itself. The ultimate fate of our journey remains an open question. Will gravity win, or will the universe's expansion pull us apart forever? Only time will tell. This cosmic dance highlights the ever-changing dynamic nature of the universe, reminding us that nothing in space is truly still. Our movement is a testament to the powerful forces shaping our cosmic destiny, and to the mysteries that still await us in the vastness of space. What is the Great Attractor? It's likely a massive supercluster of galaxies. The Norma cluster, dense with galaxies and dark matter, is central to this region. Dark matter, invisible yet influential, forms the cosmic scaffolding. The Great Attractor's gravity comes from both visible and dark matter. Recent surveys reveal the Shapley supercluster's influence, adding to the pull. Our journey is towards a combined gravitational center of vast cosmic structures. The Great Attractor is crucial in understanding the universe's structure. It confirms and tests our cosmological models, revealing the cosmic web. Studying it refines our understanding of dark matter and energy. The Great Attractor is a cosmic laboratory weighing the universe's mass. It redefines our cosmic address, placing us in the Laniakea supercluster. This perspective gives us a profound sense of place and context. Tackling this mystery pushes technological and theoretical boundaries. The Great Attractor is a signpost towards a more complete theory of gravity. Does it matter that our galaxy is pulled across the universe? Yes, profoundly. Mysteries like the Great Attractor ignite human curiosity and drive exploration. They invite us to look beyond terrestrial concerns and contemplate the universe. The pursuit of knowledge is fundamental to who we are. Astronomy expands human perspective, connecting us to the cosmos. The quest for cosmic truth unites us, transcending borders and conflicts. The universe's mysteries remind us of our common humanity. As we look up, we ride a planet, orbiting a star, in a galaxy hurtling through space. Let this spark imagination and questions, for it's about the joy of discovery. Keep looking up, for the universe is full of magnificent mysteries. Imagine a river of galaxies, billions, each an island of stars. Our Milky Way is just one, flowing with countless others, all pulled by something immense and unseen. This is the Great Attractor, a gravitational anomaly stretching across millions of light-years. Our Laniakea supercluster is sliding down this valley in space-time, drawn by its pull. The Great Attractor adds 600 kilometers per second to our galaxy's speed. The universe isn't uniform, it's lumpy, with massive conglomerations of matter. The Great Attractor is the largest, closest lump we know. This mystery beckons to the explorer in all of us. The Great Attractor is a testament to the universe's enduring wonders. Our story is just one thread in this vast cosmic tapestry. To grasp the Great Attractor's scale, we must know our cosmic address. Earth orbits an average star, one among hundreds of billions in the Milky Way. Our galaxy is part of the Local Group, a small gathering including Andromeda and dozens of smaller galaxies. But the Local Group is just a suburb of the Virgo supercluster, or so we thought. In 2014, astronomers revealed an even larger structure, Laniakea, meaning immeasurable heaven. Laniakea contains about 100,000 galaxies, stretching over 520 million light-years. At its heart lies the gravitational basin of the Great Attractor, the center of our cosmic continent. All galaxies in Laniakea, including ours, flow toward it, participating in a grand gravitational dance. The Great Attractor's mass equals quadrillions of suns, not as a single object, but as a cluster of thousands of galaxies and dark matter. This mass warps space-time, creating a gravitational low point. Galaxies roll toward it like marbles on a sloped surface. The Milky Way is moving toward it at 2 million kilometers per hour, a journey ongoing for eons. We don't feel this motion, but astronomers can measure its effects. It's a shared journey, a collective pilgrimage of 100,000 galaxies answering the same call. We are all part of a great cosmic river, flowing toward an unseen sea. This destination holds secrets about the universe's very architecture. Our place in the cosmos is defined by this invisible current. The Great Attractor shapes not just our path, but the fate of countless worlds. Understanding it is key to understanding our universe. If the Great Attractor is so massive, why can't we see it? The answer: location. It lies behind the dense plain of our Milky Way, in a region called the Zone of Avoidance. This band of sky is thick with stars, gas, and dust, like a cosmic fog blocking our view. The glare and dust absorb visible light, making it nearly impossible to spot distant galaxies behind them. For years, astronomers avoided this region, unable to see through the veil. We can measure the Great Attractor's pull, but not see its face. A classic cosmic conundrum. Yet, human ingenuity persists. While visible light is blocked, radio waves, infrared, and X-rays can penetrate the galactic smog. Using these wavelengths, astronomers have begun to map hidden galaxies, revealing a massive concentration right where the Great Attractor was predicted. The veil is slowly lifting, but the full picture remains incomplete. The Zone of Avoidance still guards its secrets, but every new discovery brings us closer to understanding what lies beyond. The discovery of the Great Attractor is a tale of scientific detective work. In the 1970s and 80s, astronomers mapping the cosmic microwave background found a temperature difference, evidence that our local group was moving at 600 kilometers per second towards Centaurus. Known gravity sources couldn't explain this motion. Something massive and unseen was pulling us. Enter the Seven Samurai, a team of astronomers who mapped the velocities of hundreds of galaxies. They found a vast region, 250 million light-years across, where galaxies streamed in the same direction. Their 1987 paper confirmed a massive gravitational anomaly, the Great Attractor, hidden behind the zone of avoidance. This discovery reshaped our understanding of the universe's structure. Gravity, acting over immense scales, assembles matter into colossal structures. We live within one of these grand cosmic projects. The mystery wasn't solved, but it had a name. The Great Attractor became a landmark in our cosmic map. It showed us that the universe is far more interconnected than we imagined, and it set the stage for even deeper mysteries. What if we could travel to the Great Attractor? It's 150 million light-years away, a journey that would take 150 million years at light speed. But imagine the voyage, leaving the Milky Way, crossing the emptiness of intergalactic space. For millions of years, darkness would surround us, punctuated by distant galaxies. As we approached, the density of galaxies would increase, a galactic metropolis emerging from the void. The gravitational environment would grow more complex, with tides from thousands of massive galaxies. Radiation would intensify as we entered the hot, X-ray-filled space between galaxies. At the heart lies the Norma Cluster, a gravitational giant with 1,000 swirling galaxies. Arriving would be like reaching a new continent. Exploration would only just begin. Which galaxy holds the true center? What secrets lie within the Norma Cluster? The end of the journey would mark the start of a new, grander exploration. The Great Attractor is not a destination but a gateway to deeper mysteries. Could reaching the Great Attractor be a journey's end for humanity? It would mean arriving at the gravitational center of our cosmic neighborhood, a feat of unimaginable scale. For a species that began on a single planet, it would be a cosmic achievement. Yet, the Norma Cluster at its heart is likely a graveyard of ancient galaxies, where star formation has slowed. Perhaps a civilization arriving here would find peace, shifting focus from exploration to introspection. But the universe doesn't end at the Great Attractor. Even this supercluster is being pulled towards something larger, the Shapley supercluster. Our river is just a tributary of an even mightier flow. The universe is layered with ever larger structures. The Great Attractor is not the final destination, but a way station on a journey with no true end. Each arrival opens new horizons, and the cosmic journey continues. Arriving at the Great Attractor could be a new beginning, not an end. Instead of a quiet harbor, we might find a bustling metropolis, 1,000 galaxies, each a new frontier. The scientific opportunities would be staggering, studying galaxy mergers, supermassive black holes, and star cycles up close. The Great Attractor would be a living ecosystem of galaxies, not a museum of the past. In such a dense cluster, intergalactic travel could become routine, fostering a network of civilizations. Life could spread and connect across thousands of galaxies, sharing knowledge and culture. This would mark the rise of a supercluster species, a new chapter for life in the universe. The Great Attractor is a gateway, not a finish line. By journeying there, we unlock the ability to write countless new stories. Humanity would become a true citizen of the cosmos. The journey would transform us, opening a future more vast than we can imagine. Every ending is the start of another adventure. So, what is the Great Attractor? It's not a single exotic object, but a vast concentration of ordinary and dark matter. The Norma Cluster, a massive galaxy cluster, forms its gravitational heart. Early estimates couldn't explain all the observed motion, leading to speculation about something even bigger. Further mapping revealed the Shapley supercluster, an even more massive structure, 650 million light-years away. The pull we feel is a combination, the nearer Great Attractor and the distant, colossal Shapley supercluster. Our galaxy is caught in a gravitational tug-of-war between these giants. It's not just one valley, but a long slope leading to an even deeper one. The Great Attractor is the nearest feature, but Shapley dominates our wider neighborhood. The flow of galaxies continues past the Great Attractor, all heading for Shapley. The mystery has grown, becoming part of an even grander cosmic story. The story of the Great Attractor is about us, our place in the cosmos and our drive to understand. This hidden gravitational anomaly symbolizes the nature of discovery. The universe guards its secrets and we must work to reveal them. The quest to understand the Great Attractor has pushed astronomy's boundaries, revealing a universe more interconnected than we imagined. With every new telescope and survey, we peel back another layer of the mystery. We're mapping hidden galaxies, charting cosmic flows, and understanding the interplay between the Great Attractor and Shapley. Each discovery deepens our sense of wonder and connection. The Great Attractor reminds us, we are participants in a dynamic, evolving universe. Our galaxy is on a journey that began billions of years ago, and will continue for billions more. This journey is humbling and inspiring, connecting us to a story larger than ourselves. We look up at the night sky, knowing we're gazing toward our cosmic destiny. Even if we never travel there, science and imagination let us explore distant shores. The quest to understand the cosmos is the noblest adventure. The universe is calling, and we are learning how to listen.